Okay, so question number 4, let's take a look at it. The table above gives values for a continuous function f. So we know to get from 5 to 2, it's connected. From 2 to 3, it's connected. From 3 to 6 is connected, and 6 to 5, right? We're not just jumping, it's a smooth line. Oh, it's not, maybe not smooth, but it's continuous. There are no breaks between, right? You don't go from a 2 feet person to a 5 feet person all of a sudden, right? You have to grow through that. The table above gives the values of a continuous function f at the selected values of x. If f has exactly 2 critical points on the open interval between 10 and 14, which of the following must be true? Okay, so a critical point is when the derivative f prime is equal to 0, right? Or it doesn't exist as, yeah, okay. But so far it equals to 0. Now, how do we get to 0? Well, if I draw you a graph of a regular function, if I say this is f and the graph goes up to down, positive to negative, you see that we have a slope of 0 here. Okay, so we have a slope of 0 whenever we change signs. That's one of the easiest ways for us to spot this. So how do we get from 5 to 2? So if I just draw these points here on a graph, let's go ahead and draw these points on a graph. 10, 11, 12, 13, 14. And you don't have to do this. It's just so you guys to visually see it. 5, 2. Sorry, 2. That's our 2. And then we jump to 3. And then we jump to 6. And then we come back down to 5. Right? So this is continuous. So we have some type of snake weaving and bobbing. Now, the question is, we have 2 critical points, and where could they be? So to get from 5 to 2, do we have to have a critical point there? No. But if we return back to 3 someplace, there has to be a critical point someplace between 10 and 12. Someplace here we have a critical point because we had change signs. Okay, because we went down, then back up. Is it exactly at 11? Hell if I know. It could have been shifted to the left. It could have been shifted to the right. I don't know. I just know it's someplace between 10 and 11. It's 10 and 12. Okay, and then going from 3 to 6. See, now we're in an upward process. We're going up here, up to 6, and then we come back down. So we know that we have another critical point between 12 and 14. So which of the following must be true? The function is positive for all values in the open interval. Are we for sure that this is always going to be positive? Could this have dipped under and came back up? Dipped under, maybe came back up? It could have, right? We could have taken a bad stock day, GameStop. So that seems like it's not going to be true. Is it true that the derivative exists for all values of x between 10 and 14? Well, are you sure there are no corners? I don't know. You didn't tell me it's differentiable. So there could be a corner here. We could have bent. There's a freaking dent in my car. How the hell did that happen? I don't know. Is it true that the slope is negative for all values on the open interval? Can you for sure tell me that this is always decreasing for all values? Well, for sure, we had to come back up. So we know that is not true. And then is it true that the derivative at exactly 12, is it true that exactly at 12, we have a derivative that's not 0? Which of these must be true? Which of these must be true? Okay, so is it true? Remember how we said we have to have a critical point either in the first part or in the second part, right? We already stuck those derivatives in those corners. So is it true? It looks like that one must be true. We said, I cannot guarantee you that. So that's false. This is false because we did have a positive increase. And sorry, this is a positive increase. And this one, we weren't sure, right? That was not true. So we are left with D to be true. Because we took up our critical point already here, and we took up our critical point here, so we couldn't give you a third one there. Okay, so that one is false. Okay, let's go through our next one. Sophia, are you okay with that one?
Yeah, thanks.
Good. Really, these are like logic battles. Logic battle 1. Doesn't make sense. Oh, what the hell is this? Oh, this is written terribly. Okay. Did yours look just like this? Because this looks terrible. Hopefully yours look better than mine. What the hell is this? There's another one on your homework today that I was looking through and it looked like this. I deleted it. I was like, forget it. A particle is moving along the x-axis so that at any time t is greater than 0, its acceleration is a. Okay, they gave us acceleration. Great, thank you. That's my acceleration equation. If the velocity of the particle at t is equal to 0, my initial velocity is already 7. I'm already running at 7, okay? Before, when time says go, I've already cheated. I'm already running at 7. Okay, that's what that means. They also told us our position is 0. Okay, at t0, we're starting at the starting line, but of course, I'm already running when the gun fires. And then the position at t is, okay, so what is the position going to be? All right, so how do we get from acceleration back to position? Well, just a reminder, if this is my position, oh no, gosh, use another pen. If we have x of t, that's my position. We take the derivative of this, we end up with velocity. We take the derivative of this guy, we end up with acceleration. So to go backwards, we're going to take the integral and then the integral. Okay, so excuse me, that's a burp. Let's take the integral of -4 sine of 2t dt. Okay, here we go. We plug it in. The integral of this is the derivative of sine is cosine. Derivative of cosine is negative sine, right? So to go backwards, we have sine. We're going backwards. This is going to be, I'm going to take out the -4 here. The integral is negative cosine of 2t and then over 2. Okay, because of u substitution. U is equal to 2t, du is equal to 2 dt, dt is equal to du over 2. That's why we have the 1/2 in the front. If you're not sure, go ahead and take the derivative. What's the derivative of cosine? That's negative sine 2t and then chain rule. Okay, so we're back to step 1. And then you have to write plus c. Just remember to write plus c. And that's our velocity. Now, we want to get the actual velocity. They told us initial condition. If t is equal to 0, the answer is 7. So 7 is equal to, I'm going to combine this, -2, +2 cosine of 2 times 0 plus c. We have to solve for c before we can take that step back, because we have to figure out what the original velocity equation is before I'm going to take the integral again. So the cosine of 0, if you guys remember cosine of 0, here's my unit circle. Cosine of 0 is 1, 1 comma 0. It's the x direction. So that's 1. 7 equals to 2 times 1 plus c. C is equal to subtract 2, subtract 2. C is equal to 5. Okay? So v of t is equal to 2 cosine of 2t plus 5. That's my velocity at t is equal to 0. If I take the derivative of that, I'm going to end up with -4t sine 2t. Okay, good. Now, to take a step back from here, we take the integral of this guy again. So x of t is equal to the integral of 2 cosine of 2t plus 5 dt. This gives us the integral of cosine is sine of 2t, 2, and then I'm going to take my chain rule, plus 5t plus c. Take the derivative of this if you're not sure. Derivative of sine is cosine. Chain rule, the 2 comes out, you're left with 2. Okay, we're in a good position. And then we're going to plug in our initial position is 0, 0. So 2 sine of 0, that's actually 2 divided by 2 is 1. That's actually a 1, save time. Plus 5 times 0 plus c is equal to, we said that's equal to 0. Now remember the sign of 0 is 0. So c is equal to 0. Our answer is 2 sine, oh, sorry. The 2 divides out, right? So it's just sine of 2t plus 5t. Okay, and that answer is, I'm looking at A. Yep, A is the answer. Now, you could have told me, Mishko, can I just take the derivative of this quickly? You could have. The derivative of this is cosine 2t 2. 5. Derivative of this again is negative sine 2t 4. Okay, you could have done that. And that's my answer. That would have probably saved me a little bit of time. But just FYI, that like all these would have been 2t's, right? Sine 2t, sine 2t, sine 2t. And when you did that, all these would give you the same answer, which would have been the wrong answer. Okay, so the answer is this one. Bobby, you have a question? Or is your hands just up? We're okay with this one going backwards? Thumbs up. Yeah, thank you. Okay, next one, 14. Okay, 14 looks ugly. Using substitution, thank you, is that dx is equivalent to, okay, all right. So we're changing x's to u's. So we just do that. It's straight algebra 2. If x plus 1 is u, guess what? You're a u now. Great, you're u. x is equal to u minus 1, right? If I just move the 1 over. So x is now u. Integral of u minus 1 over the square root of u. Great. But there's a problem. We still have dx here. Now, how do we substitute dx for du? Think about it. How can I get x to look like dx? How can I get x to look like dx? How do I like x to make it dx? Just take the derivative. Dx is equal to du plus 0. That's it. Dx is du. Integral of u minus 1 over square root of u. Okay. Now, this problem doesn't look like it's an answer yet. So let's go ahead and multiply the u on the bottom and the top.
Okay. Isn't it d?
Oh, is that what it looks like already? Maybe you're right. But so let's see, how do we get there, right? The answer is D. You're correct. The answer is correct. Oh, you just moved the square to the outside?
The u minus 1 to the outside. It's
oh, I got that one. Let's
constant.
Go.
And then u to the negative 1/2 is 1 over rad u, right? Do you have to show that you transferred it to that?
I get it. Okay. So what I'm going to do is, I'll try a different way. Integral of u over square root of u minus 1 over square root of u, which is 1 over, just to show you, because you see this already, but it's not clear to me. That's 1/2, right? So the backside that goes to the top, it's a negative, u to the negative 1/2. And this guy here, it's u to the 1 minus 1/2, which is u to the 1/2 minus u to the 1/2.
Oh, so it's not D.
Sorry, the answer was C. The answer was C. You can't factor that out because it's a variable. It's not a constant.
Oh, yeah.
Okay. Sorry about that. I was thinking your D meant my C for some reason. I was thinking D was the third letter in the alphabet. Okay. So unfortunately, this was an algebra 2 substitution problem. You could have done this also here, and that would have given you u to the 3 over 2 minus u to the 1/2 all over u, and this becomes u to the 1/2 minus u to the negative 1/2. Okay, same answer. Yeah, sorry about that. That was us factoring it out, and we couldn't factor it out. I was doing a dad thing where you're talking, but I believe what I'm doing is right, so I just ignore what you're doing and stick to what I'm doing is right. Okay. All right. Hopefully you're okay with that algebra 2 substitution. Okay. But if you guys got here, good job. That's the calculus part. The only other part was stupid algebra 2. What? All right. Any other questions that I can help you guys out with? Hopefully this wasn't too much for one night. But we have to continue to practice these questions so you guys kind of get used to this rhythm. of that's not hard calculus. I'm just literally doing what they want me to do. I'm just following the recipe. Okay? But being confident and saying, hey, I can change it, I can substitute, I'm just plugging stuff in. Okay? All right. What other questions can I help you guys with? Anyone else?
Yeah, I got one.
Yeah, sure, shoot.
So this is just a general question for these practices, but so we're not allowed to have a sheet of identities with us when we do these?
So I'm going to post up a folder of cheat notes for you guys, so you guys can see all the formulas and everything like that. But on the AP exam, no. Okay.
That's crazy.
But well in the regular test, you're not supposed to have anything, right? You just have your graphing calculator and then that's it, and you're not even allowed to use that for half the test. But it's just like the SAT. All these standardized tests is what do you know, not what can you research. So that's just the way the test is. When I ask you guys to practice this, I want you guys to try to do it yourself first. Like live the struggle. The struggle is real. Try it. If you can't figure it out, then fine. Go look at some notes. Go. Oh, I remember that it's a integral of inverse trig. Oh shoot, I don't remember how to do that. Then go look it up. Sure, but you have to tell yourself, I don't know how to do that first. Struggle, and then fine, go look it up. Because it's all this stuff that we're doing. It's a learning process. I'm trying to get you guys familiar with the test. Not really with the content. The content is like this one, find the maximum value. The keyword is maximum value. So we're taking the derivative, making it equal to 0, and then looking at the critical points, looking at the endpoints here. Look at 0, look at 6, and any of the critical points in between. So all these questions, you got to snap into it. Like what is given? What am I looking for? You got to do these questions like under 3 minutes each.
Mr. Ko, did you do number 9?
No, I can do it right now. No one asked me.
Okay.
Okay, my version of it looks like crap again. I'm not sure why it didn't load correctly, but let's go ahead and decipher what they say. So they told us the derivative is 2x squared plus 2x. Then they told us one of the initial values is 2. Perfect. So there's a couple of different ways of doing this, but I'm going to do it my no-brainer. This is how I'm going to do it way, okay? There's actually other ways of doing it. So f prime of x is equal to 3x squared plus 2x. They gave us f of 2, but they want to find f of 1. So to get from here to here, we take the integral. So this is going to be f of x is going to be the integral 3x squared plus 2x dx. Integral is 3x cubed over 3 plus 2x squared over 2 plus c. And okay, we see those go away. Easy problem. Now f of 2 specifically, and when f of 2, they told us was going to be 3. So that's going to be 2 cubed plus 2 squared plus c. So how the hell is that going to be 3? Did I do that right? Plug in 2, 2. Okay, so 3 is equal to 2. So 8 plus 4 plus c is 3 equals to 12 plus c. C is equal to -9. Okay? So when we rewrite our function, f of x is equal to x cubed plus x squared plus, oh, not plus, -9. Okay. Now, what is the value when I plug in 1? 1, 1, it's -7. So we take the integral, we plug in the initial condition to figure out what c is. We rewrite the problem so we can now plug it in easily. I think that was like a 2-minute problem, maybe 1 minute if I wasn't talking. Okay. All right. How do you guys, Max? Okay.
Yeah.
Yep.
Yeah. Thank you.
What do you think was the hard part about this question?
Well, it's not the question that's hard. It's just understanding what it wants from
Right.
me.
So the hard part was understanding the question itself, right?
Mm-hmm.
So here's how I decipher it. So I don't see AP questions really like till about this time of the year anyways, because I'm just trying to go over content. They give me f prime. How do I get back to f? Take the what?
Integral.
Right. And once I give the integral, didn't they give me 1 point here? Because when they give me integral and they give me a point, I can find out what c is.
Mm-hmm.
And then they tell me, hey, what is f of 1? Now I can plug in what 1 is. And that's actually how I read the problem. I'm not trying to overcomplicate it. I am just reading it as they write it. Okay. All right. What's another question I can help you guys out with? We have like 10 more minutes. And then you guys have like an hour lunch at home. Life is hard.
Except for seniors, we have a mandatory meeting.
Yeah, Mr. Cole, we
Aw,
have a meeting.
for babies. Oh, okay. All right. Anyone have any problems though? We're good. Make sense? If you guys do have any problems, feel free to email me. That's not a problem. Okay.